Well, here's the start of my power hammer project. Completely from stuff I've scavenged from different rubbish tips over a period of about the last week. Mostly rusted I-beams, some heavy machinery supports, and a strong thick-walled C-channel. So there's the basic layout of what will be my power hammer. At the top there we'll have the drive wheel, and then next to that on the top will be the motor. That piece of zinc tubing, that will become the hammer. This will be the die, where the dies will go, some more strengthening for the bottom. Up with the main framework, again braced at the top, and the motor will be sitting up there next to that wheel. But it's not going to be electric. I've decided to do something a bit different and put a petrol engine in there. So there we go, the beginning of the project. Well, this is the hammer for my power hammer. So that's a 100mm square, about an 1/8 inch thick walled steel square tubing, and it's filled with a big lump of cast iron, about the same size. It just fits in there, so it's bloody heavy. And on top I've welded a plate, and then welded on some water pipe, and then machined a Delrin bush to go on the inside, then with a brass washer to go there, and then with the bottom bit of the hammer mechanism to go on there, which then when it's put on goes like this. So that's going to be nice and strong. This is 25mm thick solid steel tube, again with the Delrin bush in there. And then the other section of the hammer, same process as this. I haven't drilled the holes in there yet, and this goes in there quite nice and tight. Maybe a little bit too tight, but I don't know, fits better that way. Drill the hole in there, a little bit of jimmying, and it'll fit like a glove. And this goes on there like that. So it's this is heavy in and of itself. Welded across here obviously, down inside, across the tops. Again, that should be nice and strong enough to hold this big boy here. Well, I thought I'd do a check and see how heavy it actually is. So I've got my bow weight scale there, and here's my big lump of steel, which is pretty heavy. Let's get him in there. Oh, that's easier said than done. Oh, there we go. 52.1 pounds. So what's that in kilos? I'll change that. No, doesn't want to do it. So let's just say 52 pounds. Or in other words, bloody heavy. Oops, that's fucking heavy. Here we are now with the arms assembled. Oh, looks like he's got some big shoulders. A bit brutish, all that's missing is his head. So, okay, yes. These go up like this, and then they will be on a roller up there to support the hammer. So this is what will be happening with these, up and down like that. So as this probably goes 60 to 80 times up and down a minute, jockey in here, like that, to take that load, otherwise nothing would happen because it would just squat. So the shocky is the next bit, along with the bearings at the top. Woohoo! Now I've drilled some 10mm holes in this solid inch square tubing. Well, not tubing, it's a square. I've drilled them about 10mm down, 10mm bolt in there, another one in here. Weld that on, then the shocky will be able to sit just like that. but it'll be a nicer shocky this, not this crap one. The shockey's now mounted on. We've got those bits of metal bar that I cut, welded them on, put in a dowel ring bushing, and this will be the top of the mechanism. So now the whole process, up and down like this. More than happy with that and pleased with it. Feels nice and tight. There's very little slack anywhere, which is making it hard to get it sequenced. Bit of CRC will fix that pretty good. So there is the actual hammer. On the bottom here I'll actually have bolted on the actual dies. But at the moment this is just the hammer. Okay, lovely. Here's the water pipe that I've welded to the top swinging arm, and I've spent a fair bit of time just really beefing up that section. So where the circle meets the square, there's 3 welds to get it to the edge of the square, and then I've put another 3 welds on the outside just to give it much more extra strength than what it would have just had with a single pass weld. Because the last thing I wanted was that coming off when the hammer was in full swing. That'd be really dangerous. So I'm confident that now, looking like the conrod in an engine, it'll all be good. Okay, now what we've got to do with these top of the arms, now with the pipe welded on and the bushings to be in there, is make a support bracket to hold this, which I'm using some 10mm thick flat plate. One will go behind there, one will go in front of it, and we'll have one on top there, which will mount the pillow block bearing, and then just on the sides to give a little bit of extra strength, just some more welded in section just like that. Then some 5/8 holes here and here, through there, nice bolt through the other side, and this will be our good swinging mechanism. Well, that's the plan. I think it'll work. Okay, here we go. I've made this bracket, and what I've done is welded it together, as I said, with 2 5/8 nuts welded in, space there for the top half of the rods to go in, and a place on top for the pillow bearing. So this will go on top of there like that, and then this 40mm steel rod will go on there, which will be connected to our wheel, which will drive the whole mechanism. So, oh, looking good, nice and strong. That should be mint. Well, here's the assembly, and it's getting pretty heavy now, and I was wondering how much it weighs. 82 pounds. That's pretty heavy. A lot of oomph going to be in that hammer. Plenty. Okay, here we have the wheel, which we're going to have to get a mounting on first before we can mount it to the general frame and put the offset on the other side. So, in order to mount this to the frame, I've got 2 bits of flat bar here, which I'll weld together and put those in there, and then just drill the appropriate holes and put the bolts in so the wheel will be centered. To this plate, a steel shaft will be welded to that, and then these 2 pillow bearings will go in there, just like this, like that, and then these bearings can be mounted to the frame so the wheel can spin freely, and with the grease nipple in there, it can remain nice and lubed. Very simple. Let's go to it. Whoa, 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 whoa. Let's get some of this rusty crap off so we can weld it up. I think we'll do that outside. Well, we've got that rusty crap off, so let's get the welder out, the good old MIG, and let's just tack it and then make our square together. turn him over. Let's give it a tack on the other side, then we can make sure he's flat. Now I won't bore you with the whole weld, but I'm going to weld all the way along except for the centre, because we're going to drill a hole just in there. That smoke's from oil, see? Don't want to burn out my hole saw. One last little weeny bit. Come on. Should have had my gloves on rather than sitting on the bench, but there we go, there's the hole for our axle. Well, there we go, there's our 4 holes for our 25mm centre axle and our 4 wheel bolt holes. Did those at 12mm, and I'll use some 12mm nuts and bolts, that'll be fine. Yay! Okay, here we go. Got our plate done, all welded, finished, rounded off the edges. Got our shaft. Shaft goes in the hole like that. Boom, boom. Then it needs to be square. So that's really important that this gets square. So what I'll do 4 tacks, make sure this is really square. Then underneath it's flush. So we'll weld all around there. Then when this little baby is all welded and trusted in, you can go like that on the wheel, and if it's all square, should be mint. If this is slightly off centre, we don't want any of this. Or if it's slightly bent the other way, we could get some of that. So with some of that and some of this, we don't want either of those. That's what we want, nice and smooth. It's going to be alright, I reckon. We've got our 4 tacks in underneath here. Squared up all 4 corners. There's a nifty design called hole in the bench, and we'll just weld round here. There we go. That looks alright. Not too bad. Not too bad. That's why I finished and started. Probably grind that back a little bit and just make it a little bit better than that. And I'll probably go around on the inside and do that and weld this, because this isn't really doing anything, it's just bolting on to the wheel. So a little bit more strength is better than not enough. So we'll just weld the other side. Well, all welded up now. Did a little bit of cleaning up of that weld just to make it look nice and pretty. Not sure if that's coming out, but hopefully. I think it looks pretty good. I did that because you'll be able to see this. So yeah, I like it. Yep, pretty good.